Okay, so hi everyone, and welcome to this talk about continuous deployment, a topic which doesn't sound very controversial, but I feel lots of people might have very strong emotions about it. And today we're lucky to have with us to talk about this topic, Valentina Servile from ThoughtWorks. Hi, Valentina. Great to have you.
Hi.
Do you want to maybe briefly introduce yourself and your role?
Yeah, sure. So, as you already mentioned, I work for ThoughtWorks. I have for about 7 years as a consultant. And before ThoughtWorks, I used to work as a consultant as well. So, this kind of gave me a little bit of a privileged viewpoint because I had the chance to hop from company to company to company without really changing jobs. And so I've had a very nice view of what are the most common engineering practices, especially when it comes to CI and CD and, pipeline and automation around everyone's path to production. And so I could kind of have this kind of comparative view. So much so that actually I was even luckier to work in teams that had continuous deployment for several times. So we had several clients that did that. And that's how I ended up writing a book about it, which was recently released last year. This is it, continuous deployment. But yeah, so the book kind of contains most of my insights in, comparing companies that do very, very quick deployments, even continuous, versus companies that do releases once every few days, few weeks, or even a few months. So that's pretty much my background, based in Spain and calling from Barcelona. That's a fun fact. Yeah,
Amazing.
that's me.
And thanks for writing this book. I think one of the things we are missing as engineers a lot of time is kind of the common knowledge and expertise. Lots of teams find themselves reinventing the wheel for no good reason. And on the other end, I always comment about how unscientific we sometimes are as engineers because we don't really measure things and test things, and you can't do that from scratch yourself each time. So having this type of knowledge, as you said, gathered from multiple organizations that you've had a chance to interact with is invaluable. So without further ado, let's jump into the topic. And I think for me, the most kind of glaring question is, how do you even define continuous deployment? Because I think it is kind of a fickle definition. I've heard people describe the process that they're using as continuous deployment, whereas I'm not sure other people would agree that it is being not continuous and having some manual steps, but having one pipeline from commit to production, which is perhaps what they meant. So what do you think? How do we define continuous deployment? Is it a spectrum? Is it a thing? Are there any specific criteria we need to put in place before we can call something continuous deployment?
Great. Thank you. That's maybe the most important question that I'm going to address, if anything, for the viewers. So I guess with having written a book about it kind of comes the privilege of having your strong definition. So I'm gonna just give mine. Basically, the way I define continuous deployment is compared to continuous delivery, where in continuous delivery, as we know, we should be able to release to production on demand. So deploy to any environment on demand with an automated pipeline, really good automated tests, be able to release at any moment if possible. So, trunk needs to be always in a releasable state. Continuous deployment kind of adds on top of that, not only we should be able to release whenever we want to, but we will actually release at every commit. In that sense, maybe it resembles more the second definition you gave, which is a pipeline that goes straight from one commit to one production deployment. Some people maybe use it in a bit of a roundabout way to say, oh yeah, we have continuous deployment until staging, but then deployments to production are manual because they require manual checks. I'm gonna say that that's not what I really classify as continuous deployment. Is perhaps consistent with continuous delivery, and that's absolutely fine. But the caveat that is that continuous deployment has to be all the way to production in a fully automated fashion. So from when I do git push origin main to a deploy to production, there should be no manual intervention whatsoever from the developers, from the POs, from release managers. Any other carbon-based life form should basically stay out of any deployment decision. That's my definition.
That's great. And I think there is certainly a lot of confusion about it, especially from engineering managers that I've been speaking to. I think the next obvious question is this the evolution of our craft. Like, should all systems move towards continuous deployment? Is that always desirable? Is that something that the pros always outweigh the cons? And if you're out there, if you're writing a banking service, if you're coding a cellular monitoring service, whatever it is that you're coding, you should pick up, in this case, this amazing book and start reading about how to move your team up to continuous deployment? Or is this more of a nuanced thing that will fit some projects but not others, and there's some considerations to take kind of into account?
So that's a very common question as well. Happy to address it. Actually, I wrote a whole chapter about this nuance that you're talking about. When do you know that your system is appropriate for continuous deployment? So the answer is, of course, not every system is appropriate for continuous deployment, but it is usually more systems that you think that are appropriate for it. The ones where I am very happy to negotiate with stakeholders and the team if continuous deployment is appropriate or not is the ones where it affects user experience. So let's take continuous deployment as the practice of deploying every single commit to production. Now, usually when we think of production, we think of servers that are managed by our team. But what if the device that represents production for us is not a server that we are in control of as developers? What if it's actually a device that is in the hands of users? And that is the case with mobile apps, or let's say smart fridges, everything IoT, self-driving cars, just to put very interesting example out there, or even on-premises infrastructure that perhaps our company wants to have. They don't want to use cloud because they deem that they can't for whatever reason. So in those cases, a very rapid stream of deployments to production, it's definitely gonna bug the user. I have a colleague of mine that used to complain to me every time I open Zoom, there's some kind of update going on and I can never join my calls. So I think that perhaps with those situations, it's much better to have frequent deployment schedule, because of course we want to keep production as much as possible aligned to our code base. So update it on a very frequent basis, but you shouldn't do it automatically at every commit, because the rate of commit that goes through the pipeline is usually huge. And so you don't want to bug the user either. So maybe there is when you can negotiate some deployment windows that are going to be more acceptable, perhaps, during the night, or even, in the case of self-driving cars or, important machinery that you have going on, perhaps you should ask for user consent before really deploying the software to production, because it's their device, they own it, and they have some sort of right to understand what code is running on it and give their informed consent about that code running on their device. That's, I'd say, the most interesting category of systems where continuous deployment is not appropriate that I can speak about. But then everything else, I think, is much more up for debate and trial and error. For example, a case where many people doubt continuous deployment is possible is regulated industries. Now, that's really interesting because in reality, I even have a case study in the book about a bank, which is one of those neobanks. It's called N26, where they are, for all intents and purposes, a real bank. They are subject to the same exact regulations as traditional banks are, but they do continuous deployment, and they don't do it despite the regulatory framework, but they do it within the regulatory framework. And so they satisfy, for example, requirements about oversight on every change going to production by doing pair programming and ensuring that there is always a signature by both people who worked on a certain deployment on all commits going through. They use their pipeline as a searchable index of any possible change that went to production, which tests have run on it. They don't need to fill out forms or have a bureaucratic process. We can automate those things and make life pleasant for engineers while still satisfying regulations. I'm gonna say that any system where you do control production is a very nice candidate for continuous deployment. Of course, there's some prerequisites, right? If you have a legacy monolith, perhaps it's gonna be more of a journey. It's not gonna be something that you adopt from.
I think that's a great point, and brings to mind a lot of questions. But there are two that I really want to hear more what your opinion is about. The first is, sometimes, especially junior engineers or engineering managers would think about continuous deployment as a switch. We don't have continuous deployment. The gap, technically speaking, of creating a pipeline that deploys to production with today's deployment tools is not that big. Like it's not insurmountable, and it's definitely something that can be accomplished within a few days. So kind of jumping into the water, so to speak, and kind of starting right away in a process that had no continuous deployment to just flip it on and say, okay, from now on, we'll just, instead of deploying to our integration environment and taking it from there, we'll just deploy to production, is kind of almost a decision made on a whim, just to join the bandwagon and to say, yeah, we are also doing continuous deployment. But at the same time, I've seen a lot of people live to regret that decision because it didn't come hand in hand with other things that need to be in place for continuous deployment not to be operative as a process, but also effective. And maybe, I know it's a topic that could perhaps fill a few chapters of the book. In very broad strokes, what would you say are the key prerequisites, the key ingredients or components that have to be in place, absolutely have to be in place in your engineering team before you can feel comfortable with continuous deployment being effective as a process? What are the things I need to worry about first to enable this?
As you said, I've written chapters on this. I have one in particular that is called You Must Be This Tall, as in you must be this tall to hop on the continuous deployment, right? And there's definitely a broad strokes list of practices that I think are maybe the very bare minimum in order to be confident doing it and, not scare junior engineers when they arrive on board, to not scare, your stakeholders because you're pushing out too many defects and too many deployments go wrong. That very basic list to me is, it has to start with testing because obviously we have to test our software. But there's also a bit of nuance there, right? We don't just have to have good test coverage, but we need to make sure that we have coverage at the right layers. So that's where I kind of introduced the concept of a testing pyramid. So I do want a lot of unit tests with really good coverage, but also I want some higher level tests doing a sanity check of my system as a whole, because not everything that can break is in code, and I could be, messing up my infrastructure, I could be messing up my configuration, I could be messing up like the basic running environment of, say, my Docker image. And there's many things that can break. So I definitely want a mix of tests at different levels of abstraction that gives me confidence. And one practice that really helped in that sense to me is to follow like test first approaches. So for example, TDD and outside in TDD, because those are the ones that really guarantee that every new commit, since it's every commit again going to production, has the tests bundled in. So I cannot push test coverage later as an afterthought. I have to send every increment to production where the test is written first. So there is no chance that my production code is not going to be tested, even if it goes to prod right away. So that's definitely the most basic one that I think most organizations are aware of. So test automation, if you're not doing it in 2024, then, it's time.
I think the problem is less aware of is that how impactful is your test automation, not just in terms of coverage, like the term continuous deployment. Test automation is also a lot of times very misleading because I've seen organizations that have lots of tests, they're green, they're also not very useful. We can do another podcast just about the why tests are problematic sometimes, but they tested their assumptions on their very unity, and when something breaks, the tests are green. That's by now like a common meme, like 100 green tests, but the production is in a terrible state. It's kind of like you have a lot of different memes about that. I would say if you think that the fact that you simply have unit tests or automated tests running in CI is enough, then that's probably not the case, because it could be that your tests are there, but they're not really being effective in finding regressions. They're not really being effective in testing the right things. So I think what you mentioned about the testing pyramid is really important. I actually wrote a blog post about this topic recently which is rethinking the testing pyramid, just because sometimes unit tests are very local in what they're testing. And today, end-to-end tests are just much easier to do than they used to be. So today with test containers and other technologies, it's very easy to test end-to-end without paying the cost and speed and in a kind of complication that we used to have when, 10 years ago or 20 years ago when we were trying to do these things. So,
Yeah.
and at the same time, you can get more out of the test. So I think definitely testing is a big component of it. And I agree with you. I just don't want people to kind of believe that it's kind of like a checkbox, because testing is just not a checkbox. It has to be, you need to be confident in your tests, I guess.
Exactly. Like you need to be confident that if your test suite is green, that commit is going to production 100% and you're safe. As you said, doesn't mean that every single part of your code base is unit tested. Usually that tends to be a nice side effect of TDD, but there's also a lot to say on what not to test, right? Because at some point, if you over test, you're just introducing fragility in your test suite and it's gonna just bug you more than it helps you, especially when you're trying to refactor. So Sandy Metz actually has a really great talk about this as well. I think she calls it the little magic tricks of testing, telling you what to cover and especially what not to cover, what's an implementation detail that is actually going to hold you back from refactoring. And as you said, now we have much more sophisticated tools to test at higher levels of abstraction than when TDD was invented. So very, very important critical paths of your app can also be covered by those, and they are going to give you a lot more confidence than really granular tests as well. But yeah, so a good mix is the key. And definitely being confident in your suite. Another one that to me is kind of a fundamental practice is, as you said, your test might be green, but production might be broken at the same time. That's why I like talking about observability very much and alerting to go with it. So since you're basically with continuous deployment, touching production and applying active changes to production many times a day, knowing what is the state of production becomes really crucial. So you can't kind of assume that it's one and unchanging, like perhaps it was with monthly releases. Production is always going to change every single day, multiple times per hour potentially. So that's why I advocate for having a good dashboard with your key metrics, all your golden signals, your throughput, your error rate, your latency under control, but also some business metrics that make sense for the application. So say, for example, if you're working on the purchase domain, then you want to keep track on the number of conversions, because even if your service is responding amazingly well, there might be some kind of issue if the business metrics are not coming through, something that wasn't caught by your tests. So yeah, observability is also a really big one for me. Of course, then there is also frequent code reviews, right? And this is a controversial one because I am also very against PRs. And so you might think, oh, what does it mean to have frequent code reviews if you don't have PRs? The time of writing code with continuous deployment is basically the only occasion you have to have 4 eyes on it rather than 2.
First of all, I have to say it's a very unpopular opinion to be against pull requests.
Right.
I would guess. Like, I think pull requests today are almost venerated. There are a lot of toolings around them. So it's surprising. Maybe you want to elaborate a little bit more about why you think they're not advantageous.
I'm not saying that we shouldn't do code review. I'm just saying that PRs are not the only tool of code review, and they are not the most effective tool for code review either. So I'm a big advocate of pair programming instead of PRs for a few simple reasons. One is that as a code review, to me, is more effective because the feedback comes much earlier in the design process of the code rather than after the code is written. So you kind of get out of that awkward situation where you've already done a lot of work and now somebody's reviewing your pull request, and maybe you've misunderstood something really crucial about either the requirements or the design of the system that the team is going towards. And then that person reviewing is in the awkward position of having to ask you to rework all the code. This feedback is coming a bit late. So if you move it to earlier, before you've actually invested a lot of cognitive load into writing the code and a lot of emotional effort, because we all get attached to our code, is a very human thing, then it becomes much easier to have multiple inputs into the eventual design. So I prefer it that way as a design tool, but also I think that PRs bring in a lot of asynchronous communication within the team, which means that people get blocked all the time waiting for PRs to be reviewed, right? So what you end up with is, okay, I'm done with my task, I'm raising a PR. While somebody's reviewing that, I'm gonna work on this other task. Great. Now that PR has been reviewed, but I'm an hour into this task and I'm unblocked on both. So now my work in progress is actually 2 items, whereas before it was 1. So it kind of introduces that confusion. And
So we've actually
finally,
created like a serial yet asynchronous process. So basically,
yeah,
if you're working on something serially, you're creating a PR, then you need to finish the PR. At the same time, if you're blocked, then you're context switching between different things.
Exactly. Or you can, do a very long coffee break, but then again, is that the most efficient use of your time? Maybe yes. I don't know.
If the coffee is good, then perhaps.
Yeah. But my most important point why I don't like PRs is that PRs imply the using of branches. So I'm also kind of against branches. I'm a trunk-based development person. And that is because, and here I'm gonna kind of refer to, Martin Fowler and Dave Farley. I believe that it's the simplest and most productive and straightforward way of doing continuous integration into main. When you rely on branches, especially long-lived ones, they tend to accumulate a lot of changes. It becomes very easy to do the wrong thing, which is to delay integration with the mainline and just add yet another commit and another commit so that now your diff has become huge. What's going to happen when you finally raise a PR and then merge is that you're going to have a diff that is much bigger with maybe hundreds, even thousands of lines of code changed. And that means that your deployment is going to be much bigger and you don't have now the time to check it manually because you've removed the human gate blocking production. It just becomes a much more risky deployment. Which is why I kind of advocate for pair programming and track-based development as a style, especially with continuous deployment, because ultimately the main de-risking of deployments to production going there automatically is that the deployments are very, very small. If they start being huge because you've raised a huge PR, then that's when we start having problems.
I would just add to that what you're advocating for is not just a technical change. Don't call it a PR, call it a commit, and aggregate the same amount of changes, just push them as a commit instead of create a PR. What you're advocating for, if I understand correctly, is to develop a little differently in that plan out your code change. Let's say I want to introduce a big feature. I can no longer create this feature over 3 days, create a PR and have somebody look at it. I should start breaking it into very short increments, very short commits. Each one of them should be planned so that it doesn't break previous functionality or it is kind of safe to introduce or it's feature flagged or whatnot, so that I can continually add the code with short iterative commits using pair programming, like you said, throughout that process. It's kind of a very big breakaway, maybe I think, from both
cultural
teams
change.
develop. So that's why I want to just emphasize that, because the way you're describing it, it sounds extremely easy. It might still be easy, but I think the main point is that it's a bigger change than just technically losing PRs and moving to pair programming. I think that where most teams will need guidance is how does the process look like, where you really need to think about each next step and how to move it fast enough so that you don't end up accumulating all of those changes, because then you'll be in a worse state than having a PR, because you'll have a mega commit instead of a PR with multiple commits, which is also very harmful. But would you consider that to be an absolute necessity for continuous deployment, or just maybe a best practice from your perspective?
I'm gonna say, from my perspective, it's an absolute necessity. Not because you can't do anything else to de-risk deployments going to production. Again, you can put tests, you can put observability, but is essential to use certain kinds of tools in order to be able to publish work in progress to production. And the best use that we can make of those tools is with very, very tiny incremental changes. So as you mentioned, feature flags, that becomes a must-have, right? Because we don't necessarily want to release something to users every time we want to do a deployment. Those two become very orthogonal decisions that can go their separate ways. So if I have to have feature flags, then why is it that I am hiding work in progress in a branch rather than under a flag where it can be in production right away? I can test it for myself in the most realistic production environment of all, which is, again, production. You're basically having all of the downsides of having a lot of code inventory going in production at the same time with none of the benefits, which is that you would get to test it maybe in staging, because you cannot do that anymore. You're in continuous deployment world. So you're getting so much risk for essentially no reward, right? Instead, you can do other things to hide code, as I said, using feature flags, or another pattern that I really like and that I go throughout the book mentioning it is expand and contract, which is one I use for refactoring a lot. So being able to push tiny, tiny incremental changes, even when you're doing a massive refactoring. Like one of my examples is changing out the whole persistence layer from under the feet of the application while still doing teeny tiny deployments to production. So it is definitely possible. As you said, it's a huge cultural undertaking, and I believe that it is kind of a must for continuous deployment. Of course, you can do smaller branches and very small PRs and still achieve the same result. But I believe that with rank-based, if you can do it, it's the easiest, most straightforward way to encourage everyone in the team to do the right thing and get them thinking immediately about what increment of code they're gonna start with, because it is much more immediate as a feedback to get when you're on main rather than when you're on a branch, and you can just stay on the branch indefinitely. You know, it doesn't come as natural to think in terms of code increments that must be backwards compatible. Those are the main practices that I advocate for continuous deployment. There's also really obvious ones like zero downtime deployments. Maybe, again, it sounds obvious in 2024, but not everybody has them. So I'm just gonna say for the record that if you deploy to production many times a day, you can't have a maintenance window screen to show your users. You know, you need to make it absolutely seamless. And that, you know, you can do blue-green, you can do rolling deployments, but actually you need to also worry about what happens to your app if you deploy it more frequently. So if you're using memory caches, for example, those caches are gonna be called a lot of the time. So how do you perhaps externalize those caches? Or if your system deals with internal state, then you have a problem, right? Because your internal state is going to get lost every time you replace application instances. So that state must be externalized.
I think there is definitely a trade-off here, and we need to be maybe honest about the trade-off as well to make a conscious decision. But maybe before we dive into that, you touched on something that's really, for me, hits a nerve, which is observability. So you mentioned observability and you mentioned dashboards. I've kind of had a long and bitter experience with dashboards. I think it culminated when I had a visit to an offices of a big company in Israel, and their engineering manager kind of walked me around, and I saw the huge LCD screens in the corridor, and they were showing this amazingly sophisticated, multi-dimensional graphs about the state of the release and all sorts of metrics. And I thought, whoa, these guys are way ahead of anything I've ever seen. I have to learn from these guys. And then I sit with their VP and I'm asking, okay, you guys are amazing. Tell me all about how you do dashboards and observability. And he said, well, I'm kind of sorry to disappoint. I just had a conversation, like a review with one of the employees, and we talked about that. And he said that he just always assumed that these were just screenshots. He did not even understand that they were dashboards. But I think it just goes to show about how, and I think this is downright true for almost every organization that I met, how ineffective we are sometimes at using observability data. And I think, like you, that observability is key for continuous deployment. I think that it's not just key to seeing problems in retrospect, meaning something just happened and I want to react, being reactive, but it is also key to understanding how to code better. If I write a piece of code and I know how it behaves in production, who's using it, what are the performance levels I should be expecting, are there any blocking things I should know about in this flow? All of these things are information that need to flow back to the developer even as the code is being incepted. And circling back after I've pushed my code, I always argue that it's not push and pray. It's not committing and then forgetting about it. At some point, you need to have this closure of understanding, hey, my code, somebody's actually using it, and this is what I'm seeing. And dashboards are a problem because somebody needs to watch them, and alerts are often a problem because they create a lot of noise. So finding the way to actually make observability impactful, to me at least, is kind of my personal passion, because I think it has a lot of potential to shape how we write software, and definitely if we want to move forward to continuous deployment. I would argue we're running blind if we don't have observability that's actually useful and not just kind of pretty dashboard on an LCD.
I'm a big believer that all the teams should be very, very intimately familiar with the dashboard. And it means that it also has to be simple, right? Of course, you want all the very detailed graphs somewhere, but maybe not in your main dashboard, like to me, the ideal dashboard is one where you can basically have it on a screen in the room. And if you're not even looking at it, but from the corner of your eye, you see something red, then you should know that something's wrong. Of course, you're going to have alerting for that as well. But my point is, it has to be simple and straightforward and just give you an overview of what's the health of my system. Is it performing well? I can see it at a glance. And the whole team should be so comfortable with it and so familiar with it that they shouldn't need to look too deeply into it either. So yeah, actually you've touched on one of my favorite topics there as well, because I also believe that having good observability that the team is familiar with, it also improves how you write code, right? On one of the systems that I was working on where we had continuous deployment, for example, we had many downstream systems, and our dashboard really reflected that, we were showing constantly which circuit breakers were open to which downstream, how much time was being spent on which one. And, we really showed like the accumulated latency for every request of this setup, so that basically every time we had to change that architecture, yet another downstream call, then the whole team was incredibly aware of, hey, that means that we're going to have this much more latency in that graph over there. How can we ensure that we keep the system overall stable? So yeah, it was really feedback going back from how the users are really experiencing our system that we're building. It was much more precious than, just basic troubleshooting. It was also giving us, this heartbeat of how the system is working, what is the impact of our code. Another really good thing we were using observability for was with the help of feature flags. We were able to use a feature behind a flag, only testing it in production for one user that was enabled. But also through the observability, we could get immediate feedback on, hey, actually this flow in production takes much longer than if they did staging, because for the simple reason that there's more data, collections are bigger, infrastructure is slightly different. So it could be a really, really impactful design tool, not just a troubleshooting tool.
I think this is where also there's a lot of tools in the market. Full disclosure, I'm also involved in one such tool, which is for analyzing observability. But I think in general, there is a lot of room in the market today for tools that take that extra step, like what you described, that in my peripheral vision, kind of in my spider sense, I'm noticing the dashboard is red. That's good. But wouldn't it be amazing if we used AI or whatever other toolings we have to know that the dashboard is going to be red in a few hours? And not only that, to fine tune which commit, which area in the code that was affected is kind of responsible for that. And for the developer who wrote that, provide that as a feedback as he's working, so he can already look into it and see if there's an easy fix or something else that needs to be triaged. And when I look at kind of the future of where it's going, of the role that observability can play in our development processes, it's exactly that. It's how we can get more information to be more useful, because I think there's a huge potential. What you're describing is absolutely necessary. I think it's just as we evolve and we have better toolings, we've all been kind of sidetracked by AI that can generate code. But AI that can understand how the code runs is equally as important, because otherwise you're just generating code faster, but you're not learning from it faster.
Yeah, exactly. And I think continuous deployment really helps in this direction as well, because, even the tiniest one line change can drastically impact how the system behaves in production. So if we can keep those bundles of lines change that go into production as small as possible, then we also have the maximum granularity with observability to really see what's the impact of the system from one commit to the next, basically.
Exactly, which is another great point. So that observability should have that granularity of understanding commit hashes and understanding kind of the timeline in commit hashes and not just the general timeline. Two other last topics, maybe before we run out of time. The first one is I think you touched on it previously, which is blue-green rolling deployments, canary deployments, alpha. I've recently heard the term black alpha. There are lots of different things and kind of methodologies going on, which I think sometimes are used to kind of sweeten the pill of every change is going to affect all of my users all at once. No, I need some kind of a way to make that more gradual. At the same time, I guess we also run the risk of making a very non-impactful canary, let's say it's like 0.1% of our users, to be the new trash bin stage of the pipeline. So yeah, it's okay that it's broken, it's not affecting a lot of people, and we kind of expect that we learn from where it fails. So where do you stand on all of these different strategies as opposed to pure one check-in goes into production, everybody sees it?
So one thing that where I make a very big distinction in the book that I think is fundamental is any deployment strategy you use, if unless there is a real regression, the deployment should be automated. So you're not, let's say, running blue-green where you stay with half your infrastructure on version n.1 and the other half on version n for like a week to see the impact on users. That is the job of your feature flags and of your A/B tests, your releasing process. What you really want to measure with that deployment is infrastructure-wise, is version n+1 production worthy in terms of basic things like, does it respond to health checks? Does it have good enough performance on some very key things? Basically, I would like to avoid this situation where only part of the infrastructure is part of an experiment and the rest is not, The most that I feel like I'm comfortable with is these canary deployments where we use actually observability to feed back into the system that is deploying to say, actually, don't just give me the health check, give me also some basic metrics where I can see this instance is really healthy and then I can roll out my changes. But crucially, those are automated and they should be automated. So I should expect that a deployment doesn't really leave my infrastructure in an in-between state for more than, I'm going to say 1 hour. Like to me, 1 hour would be the limit because I would like each and every one of my commits to be in production in a reasonable amount of time so that I can make informed decisions about the state of production. It's not in a half and half hybrid n+1 state most of the time. It should be most of the time aligned with main. Where I do see experimentation is with feature flags. So that to me is my releasing tool where I can do a canary. And I can do a canary with an interesting portion of the traffic if I want to. So perhaps 1% is enough to deem a feature worthy of the users. And then I can roll out incrementally to 100%. Or, maybe I want to run a longer A/B test where, perhaps with, say, 30% of my traffic, I show two variations of the same feature. And, then I can figure out, okay, with some statistical significance, is this feature good enough or does it need to be thought again? I think we should use some more scientific tools like the ones offered by many feature flag frameworks to decide what is going to stay in production. We shouldn't use basic infrastructure deployments to make those decisions, right? Those are not evolved enough. They are a bit dumb, like they just speak in terms of application instances. They don't speak in terms of what kind of user is seeing this feature, what kind of journey did they have through your platform. They are just really too basic and also they crucially get in the way of getting a steady stream of commits into production continuously. I'm not sure if I answered your question.
I think maybe one last question is maybe more relevant to those who are listening to this who are not currently doing continuous deployment, at least not in the strict sense that we've defined here, where there are no manual steps, there is no intermediate step that is actually not continuous, and so on. I'm going to challenge you for a sec. I've read your book. I understand the theory. I know what I need to do. But as you mentioned, one of the challenges is how do we not or change the process so we do things very, very incrementally. And in the move towards continuous deployment, I need to do things incrementally as well. I'm not going to say, hey, everybody, hands off the keyboard. We changed to continuous deployment. Now you can keep coding again. So if I were to choose, if I'm an engineering manager, I'm working maybe in a legacy application, maybe I have processes that they're not waterfall, but they're not like top notch. I do have integration tests. I do have some foundations, but I want to start taking the steps towards continuous deployment. So how does my journey look like? What would you say are the best first things to concentrate on if my goal is eventually to reach continuous deployment? Where should I start?
I get this question a lot. I think the key here is to make it safe before you make it fast. So focus on all of those practices that promote safety rather than speed. Perhaps this could mean adding your test automation and maybe reviewing your test automation with the team. What are the types of tests you need, and so on. Look at your observability first, because that gives you more information, which makes it safer to figure out what happens right after a deployment. A feature flag framework that is good enough to do rapid rollbacks, for example, that is also making each and every one of your deployments safer. Then after you do that, that's when I would start going towards practices that are going to make you faster. So say if you're bundling a lot of commits into a branch, maybe start reducing that number, release more frequently, then perhaps after that start thinking about moving to track-based. To me, the key is if you invest in all of the safety practices, then it becomes much more painless to release more and more often, because you see that all of the bad changes get caught much more easily, and if they make it to production, they get rolled back much more easily. That's my general recommendation. And if you already arrive at a state where you can deploy on demand, so even just a basic continuous delivery state, you're already in a great place. Like, you're already ahead of so many other companies. Like, I'm not sure if you've read the State of DevOps report, but you're already an elite performer there. I definitely believe that continuous deployment adds an immense amount of value on top of that, because it just makes the development process so much easier and faster and straightforward. But you can stop at continuous delivery, right? And the beauty of this is that if you implement all of those safety practices and maybe review your speed focused practices to release much more often than you needed, you're already getting a lot of the benefits, right? It's not an investment that if you don't go 100%, you're just going to throw everything away. Like, any step in this direction, like even the smallest one, is going to bring a net positive. Is already going to be a huge return on investment, even just rethinking your test suite. So,
Even if you don't end up moving to continuous deployment, these steps
exactly.
will benefit you quite a lot as intermediates, which I think is a great thing to show for. And I think ultimately there is a trade-off like everything else. It's just that understanding the trade-off means you need to understand that there are kind of pros and cons in both situations. People sometimes have the psychology that if they have an intermediate step, like a staging environment, like an integration environment, like this place where the release pauses, then they gain more security about possible issues. But at the same time, they're also accumulating a lot of changes that are untested.
Exactly.
And their testing aren't really covering. So then pushing that in a bulk is sometimes much riskier than pushing an individual commit. So there is a fine balance there. But like you say, I wholeheartedly agree. And I think we can finish on this note that kind of the key is making sure that the changes are safe and that you are actually looking at all of these things like tests and observability that are giving you a lot of feedback. So Valentina, first of all, thanks so much for this conversation. I've learned a lot and I feel that I have a ton more questions, but we're out of time for now. But thank you. I think this topic is extremely important for any engineering manager, whether they're on the way to continuous deployment, whether they're considering it, whether they think that it's not possible in their organization. There are things that you can do and things that you should invest in. And definitely the book sounds like an amazing resource as well that you should have.
Thanks
Thank
for
you so much
reading
for
it.
talking to me.
Thank you. It was a pleasure.